Hi. Uh, Hi, Gajendra. I hope I am
Yeah,
audible.
yeah, Anil, you're audible. Sorry, I was.
Okay, great. Okay, so we have ITI Saxena with us.
Right. Hi.
Hi, ITI. Hi, Saxena.
Hi, it's Iti. Good evening, Anil.
Okay, ET. Okay. So this is your first class, I suppose.
Yes, I was in another class. They asked me to join this one from now today onwards.
Okay.
I missed one session or two. I'm not sure if it's two or one.
Okay. So today's session we will be discussing our introduction of DevOps, probably if time permits, Docker and GitHub. These are the uh, three points of interest we are going to discuss about. We are going to learn about either. I think so. Yeah, I know about other guys. Just curious about you are an experienced person or you are a fresher.
Yeah, I am 7 years experience. I have 4 years experience in data science and learning ML ops now. So just have the,
Okay.
yeah,
So you have used GitHub, right? Or
I've used it.
okay, cool. Okay, I think we have Pranav, right? Pranav. Okay, today I can't see Rick hasn't joined yet. I think Rick will join soon. Cool. So last class we just had an introduction of Python. Actually, we had our hands on in Python, and I hope everybody in the last. Hi Pranav. I thought Prerna. Okay, Prerna is a new joinee. I think so. I thought Prerna is Pranav, but Pranav is logged in as a with different account. Okay. So Prerna is it's your and the new class, I suppose, right?
Yes, Anil.
Okay. Okay, great. So last class we had a discussion about Python actually. So we introduced Python and how it is useful for DevOps, and we did some hands-on of Python. I think everybody is comfortable with Python right now. We had a very cool app actually to in GitHub, which I shared with all our team members. Probably I actually I'm very excited to share with new members also. So probably I'll share the link also. If you are interested, just have a look into that particular GitHub link, and it's very fun to actually play with that particular. It's basically a WhatsApp bot. I'll just reshare it again. Probably you can just follow the instructions in the README and see if you can make it working. So I'll just share it as an extension for the last class, previous class. Mhm.
Do they have any Discord group for this course?
We have a WhatsApp group actually.
Okay.
Yeah, probably I will ask Gajendra to add you if you're interested.
Mhm.
I think Gajendra is already there. Gajendra, if you are okay, then we can add Prerna, right? We can add Prerna.
I'm sorry. Could you repeat that again? I was not available. Sorry.
So I think Prerna is not in our WhatsApp 6 batch WhatsApp group. She
Right,
was
Prerna. I'll take care of that. I'll add you to the group.
okay.
Anil, I am there. It's ET, I guess.
Yeah, it's me, Iti.
Okay, ET.
Okay,
Okay.
Iti, I'll approach you and add you to the WhatsApp group.
Sure. I think I have the link. I'll join. Yeah.
All right. You can also go to the first in under my courses in DevOps batch 6 in the first topic session recordings. In the description, you can see the WhatsApp group link, and you can directly join using that link as well.
Sure. Thank you.
Right.
Okay, so I'll just share you one particular. If you are interested in previous classes, Python basically. So a simple GitHub link I'll just share you in our Zoom chat. You can just read the instruction that will give you a quick hands-on on coding with Python and how you can develop a real-time application in Python. Just I'll post you that. I have chatted in Zoom chat. I have just posted that GitHub repository. Please read into the description. It should be very straightforward, very simple. But you can actually admire the power of Python. How you can actually build a WhatsApp within few minutes. Yeah. So coming today's topic, we will start. Our agenda is to actually introduce DevOps and then GitHub and if time permits, Docker. So this is the basic agenda of um, today's session. So basically, we already know what we want. We are in the DevOps session, right? We already know what we want actually. So this is about like just I would recommend to go through the DevOps session, and it's all about what are the roles, what are the tools that we use in DevOps. Um, yeah, so let me quickly start from there actually. So what do we want? Meanwhile, if required, I'll skip that and I will when I actually do the real practical implementation, I'll come back there. That way, I think it will be more interactive and more understandable to everyone. Yeah. So let me share my session now. Share my screen. Sorry. Let me share my screen. Mm. Okay, I hope everybody is able to see my screen. Mm, so we will go to our topic now. So we have covered Python. Now, basically, our plan is to get into DevOps actually. So we know like we already had list of all software and tools which we are supposed to learn as a part of DevOps, right? So out of which so this is all about the theory of how the DevOps came into picture. I don't want to make it more complicated. So basic idea how the DevOps role came into the requirement in the current industry. Um, so basically you can easily understand by looking into the cycle because I see that all are experienced guys here. Few people are 10 years experience, few people are 13 years, and I new guys are about like 7 years experience, right? So I think it's very much it should be clear to you as you already should be having some hands-on. So just I wanted to give you an overview of. I would also recommend you to actually when you have time read look into this video. This is video by our Cloudx founder Sandeep Giri. He has given a session. It is a 2-hour session. Please look into this. Why we require DevOps? What exactly are the different phases of DevOps? Please have a look into it. So basically, they clearly and slowly explain step by step of different phases of a typical DevOps role in the industry, right? So let me know. I think everybody, I am audible to everyone, right? I think I am audible to everyone. Okay. So, right, you all guys are software engineers, right? You all guys are software engineers, like basically how the software cycle works, right? So as a process of software cycle, you might be seeing the same thing here. But what it takes to have a different kind of cycle, including extra things like release deploy also, right? So this is basically the role of DevOps. So the DevOps is actually DevOps engineer. Basically, DevOps engineer is everywhere. He is there from the start of the development process, like from the planning stage till the release stage. So he is everywhere. DevOps is actually active everywhere. So he is the primary point of contact from the beginning of the software development till the release of the software. So that is a basic idea that you can see here. right? So if you are a simple developer, your role is to actually develop your own feature and enable it into the product. But the DevOps role is like, it is more visible across the product actually. So here you can see that from this particular cycle. So why DevOps? Like, so before DevOps, right? You might before DevOps role was there. Before there were purely completely different roles. Like developers used to develop their own code. Field testers used to test the code, and they used to completely give it give the complete artifact to a completely different team, and who were supposed to be like experts in infrastructure management, who were actually owners of the production machines. They used to take the artifact, they used to take the responsibility of the the code, the application. They used to take the responsibility, interact with the developers, how to follow the steps, and then used to develop, they used to deploy in the production environment. That actually led to a huge knowledge gap. So like the division was completely disjoint, right? So when it comes to when it comes to adding a new feature, again the knowledge transfer uh, to a completely different team who were completely unaware of what the changes were going on, and they were not in the they were not in the process of they were not in the process of the development or testing or plan cycle of they were not in the cycle. And when it comes to production, it took like it took many days or minimum many days or weeks to actually deploy a new feature into deploy a feature in the application which is already running in the production. So that was the main problem. So smart guys actually came up with this particular role called DevOps. So they said that why don't we have a complete cycle for DevOps who will be responsible from the start of from the beginning of the software cycle, right? So that was a basic idea. So that's a basic idea here. You can see that there is a plan, code, build, and test. So DevOps is everywhere. You will see where how the DevOps is everywhere. So you might have heard about at least the continuous integration, continuous delivery, continuous deployment. You might have heard about these terms, right? So that is what the role comes when it comes to DevOps, when it in the coding cycle, from the coding cycle itself, from the planning cycle itself. So when the actual application is under plan, then only the role of DevOps also comes into picture. How do I enable the developers to write test? How do I enable the developers to how do I provide the developers a infrastructure so that he can test his code immediately? He can test his code immediately. And how do I automate it so that next time no regression comes back? Regression, you might be knowing, right? You are all experienced guys, right? So like how do I save my time by not introducing the same bug again and again? How do I automate it? How do that's a basic idea. So from that came into a huge set of ecosystem which is called continuous delivery and continuous integration. So continuous integration is all about making the build process, making the test process automated. So we have set of tools that we are going to learn in upcoming sessions, how to do the continuous integration, continuous delivery. So basically, as in the previous session I have already discussed, I will reiterate again. For continuous delivery and continuous integration, we have many tools, out of which few are like GitHub. It has its own tool, and other standalone tools are there, like Jenkins provides its own tools for continuous integration. It's a very famous open source tool, which is mostly used in majority of industries, and it gives an idea of how to integrate with other parts of the code to enable the continuous integration and continuous delivery. So basic integration, by the word also you can actually guess what is continuous integration, right? So continuous integration, you already have a code, you have a huge code base, and you as a developer, you are introducing a new feature into it, right? So by introducing new feature, your new feature should be compatible with the existing application, right? So that's the basic idea. Like, how do you continuously have an infrastructure so that it will integrate with the existing application? So that's the basic definition of continuous integration. So once you integrate your feature as a developer, you should be provided with a very well-known, matured infrastructure set of tools which helps you to identify if there is any problem in the integration process, right? So that is what is called continuous integration, and followed by after integration you should be able to deliver the code, right? So that is called continuous. That means you should be able to deploy a new version, you should be able to build a new version automatically. You should not be rethinking every time, like, okay, now this feature comes, what are the steps I need to follow to actually deploy to the production and so on. So everything should be automated, and it should be matured enough and flexible enough to take any new changes, right? So that's the basic idea of continuous integration and continuous delivery. So there comes the DevOps role. Actually, there comes the DevOps role, and we have a huge set of tools which actually enables us as a DevOps engineer. We use those tools to enable these concepts. So basically, by these concepts, with automated tools and so on, our delivery cycle, deployment cycle has reduced as drastically, like exponentially it has reduced, right? Before we used to take, there was something like agile development process, right? We used to have scrum meetings, we used to have sprints, like, so like we have reduced from developing a big product from months to weeks, and now with a very mature DevOps process, right? It can take within few hours or few even like instantly, right? You have new feature, you just add that feature, automatic our DevOps cycle will take care of everything. It will actually just validate it whether your feature can be added or not. It will have a set of gateways, and which if all the gateways are passed, then only it will allow us to go into the deployment and delivery cycle. So now the deployment into real production has reduced drastically to like few hours. Within few hours, you can actually just ship new feature and feature. So if you have smart developers in your team, and within hours, your code is in production. So that is what the beauty of DevOps and its supported tools. So that's why the DevOps has been evolved to this particular stage, and all industrial experts are actually looking for real develop experts who take care of automation, because it makes their life easy. It makes their product to be visible to the market within few hours, right? So you build infrastructure, proper infrastructure, which is good infrastructure, good ecosystem for DevOps engineering. You are ready to actually put your business logic into production. So that is the basic concepts of DevOps, right? So in this process, we have seen like, so I already discussed, right? So what is a problem we used to have before? The shipping cycle has been reduced from weeks, months to within one day. What we can say, we can ship in one day. So that is a value addition that DevOps gives to every company who follows the DevOps engineering process. Okay. Yeah, so you can just see, so we here all our old employees, founder of our companies, co-founder, and senior instructor of our company, as we've seen. So on, just look into the slides, and it's all about more about like theory and what we are overall going to cover as a part of DevOps engineering. So I haven't finalized upon, like, we will be doing hands-on on a particular cloud platform. In these slides, we are going with AWS. I am comfortable with AWS too, but as time permits, I would actually plan for the next session. Maybe I can actually give you a running demo on Azure as well. I think with that, you will feel comfortable saying that, okay, the concept can be utilized in any cloud platform, whether it is Azure, whether it is AWS, whether it is Google, GCP, everywhere. The concept, once you know the concept of DevOps, right, you can actually use that same concept in any cloud platform, out of which right now we have 3 famous cloud platforms. There are many other other small players also in the market for DevOps engineering. Okay. Yeah. So this slides covers the same concepts. Why do we need concepts? That's I have discussed right now, right? So so that is what we are covering as a part of DevOps engineering. So understanding the requirement, what is a perfect, how to enable, how to write a perfect code, how to deploy it on a very powerful server. So these are the questions that a particular DevOps engineer actually solves, right? Yeah, so these are things. These are the things which I have already discussed right now. Software development is a continuous lifelong process, not one time, right? So it is not. It is not a once done. It is always a evolving cycle, as you have seen in the top right. It is always evolving. You plan, code, build, test, release, deploy, operate, monitor. Again you start back to plan. When a new feature comes, again you start planning, coding, build, testing, and so on. So it is not a one-time process. It is a continuous process, right? Yeah. So it is a continuous process, and we should be able to build the product in incremental phase. So we just generally it is general practice of the software engineering, right? So you can't build the whole product within one day. Rome is not built in a day, right? Similarly, software can't be built in a day, right? So you build the software in incremental phases. As incremental phases, in every phase you have to follow this particular cycle. You always want to have to follow the particular cycle so that you are actually shipping a stable, resilient code, right? So that's the basic concept. So these are the questions. Why do we need a DevOps, right? The rule of the thumb is, right, if you are doing the same thing again and again every day, right? Every day, so best thing is like automate it. Right? Every day you do the same thing. You don't want to do the same hard work every time, right? So every time you have to integrate the software. Every time you have to deliver the software. Every time you have to deploy the software into the production, right? So these are the everyday tasks. For every commit in GitHub, we say it commit. For every commit, you have to do the same thing, right? And if you don't automate it that means like you are actually making your software process a very big pain. Like you are wasting all your human resources on it, and ultimately some errors will come up because of because of few human related errors and because of knowledge transfer problems and so on, right? So the rule of thumb is always, whenever you have a repeated process that is going on in a software cycle, automate it. Always automate it. Make it automated. Make your life easy. So things which can be done within days can be done within minutes once you make it automated. Put your effort one time and you reuse it every time. So that's basic idea. So that's why the DevOps solution came into picture, right? That's where the DevOps solution came into picture. So benefits of DevOps, that's I have already discussed. Quickly, I have discussed the same thing, right? So that's a main advantage of DevOps is the rapid delivery. You can just deliver. You don't use your resources. You don't use your hard effort, your time on actually trying to find the bugs, trying to find the regressions, reintroducing the bugs. So you don't do the same thing again and again. You just automate it and mainly focus on the main business logic of your product, the main features of your product. So that actually enables you to deliver the software pretty fast, right? So those are the basic advantages of DevOps: rapid delivery and reliability. Yeah. So when you have less amount of when you automate things, there are less human errors, right? So reliability is also increases, and scalability. So scalability and speed also can be automated with DevOps, right? So if you imagine that you don't have any automated system and you are manually doing the scaling logic, you instead of manually doing the scaling logic without any tools, like is a very big headache, right? So in real-time productions, right, environment, suppose you are a employee of big giant company like Google, right? So Google, it's everywhere. It has thousands of servers for a single product, right? So in order to scale the machines, in order to reduce the number of machines when there is less demand, is like a repeated process, and that's uh, that's a pain. That's a pain if you are doing this manually. Actually, it is not feasible to do manually for to the scale of Google. So for such things, you have to automate things, right? So that's where the Google, that's where the DevOps tools come into picture. Like you have a specific DevOps tool. In this particular case, a tool like, for example, Kubernetes. So Kubernetes, using Kubernetes, you can actually scale up, scale down the number of machines, and you just need to have a mathematical formula there. You need to identify the core logic of when to scale, when not to scale. You need to think or plan over before only and give that particular plan to Kubernetes, and your life is easy for you. So you have a very proper plan, and you provide the plan to the DevOps tool, which is Kubernetes in this case, and it automatically takes care of scaling up and scaling down and so on. So that's a basic advantage of DevOps engineering. So you can see that by using DevOps and its automated tools, you can actually have a rapid delivery. You have reliability. You can trust it. Actually, you have reliability, and you can scale the application. You are increasing the speed, right? So these are the basic advantages of DevOps engineering. Yeah, so this is all about theory. We'll go into how practically how it is going to help us, right, in real time. What are the different tools that we are using to achieve this part, all these features as DevOps engineer. So we'll go through that. Yeah, so you can quickly divide this particular spiral into two parts: development and ops, as I have already discussed with you guys. So development, in the development part is like all planning, coding, building, and testing. And in the operations part, it's all about trying to release it, deploy it into production, operate on it. Like you have to, and afterwards you have to continuously monitor it, right? So you have to, your production is there, you have to continuously monitor which servers are getting out of memory, which servers are maybe hanged, which servers are getting down. So we need to have a monitoring tool also. So all these things are achieved via automation in DevOps process. Yeah. Yeah, so we have given a quick overview of in the plan what are the tools we are going to use in coding, what are the typically in coding, what are we going to use, and so on, right? So you might be knowing this, all these tools, right? Google Docs, Google Sheet, planning. Like planning is all about like requirement specification gathering and try to build a system design, like how your product should be there and so on, right? So the tools that you actually use, list of all tools that you use, like Microsoft Office, if it is Google Docs, Google Sheet, process management tools, and tracking, task management tracking tools like Asana, Jira. There are many other tools like Twilio. There are many other tools also. So we use these tools in case of planning. For coding purpose, we use one of our favorite editors, which are particularly fit to the environment, specific to the programming language also. Nowadays, most evolving, I feel, which is most evolving tool is like Visual Studio Code. Everybody is using Visual Studio Code because it has a very fine plugin management system. It has plugins for everything, almost everything. So I feel like Visual Studio Code is being used in every company. Every startup is actually moving to Visual Studio Code instead of relying on different IDEs for different programming language. Like Python, people used to use PyCharm, and for C# they used to do Visual Studio. For example, Golang, they used to use different editors. But Visual Studio Code is a very fine IDE. Using that IDE, you have plugins for every programming language, for Python, for Golang, or for Java, or for .NET, anything. You have a simple programming extension. You just need to add that extension. You are ready with coding it. It is very fine and a very stable IDE, and open source also. It is free. You can download the Visual Studio Code IDE for free and use it. So this is what generally I feel like in coding most of the people are using nowadays, and it is for every operating system. It is we can actually work on it. Any Visual Studio Code is supported in all operating systems, almost all operating systems. Yeah. So Yeah, so basically, so we have other tools also like Git. Git is like the buzzword for any software engineer or DevOps engineering specific. You should be, if you are a DevOps, you are supposed to be expert in Linux. You are supposed to be expert in Git, and to some extent to be expert in Python also. So these are the must for any DevOps engineer. You should be having a very good idea of the basic functional idea of Git, basic fundamentals, how the Git works, how it is different from, there is no competitor for Git. That's what I can say. Like before, there were other version control systems, SVN, clear case or something like that. There were many other version controls. They are nowhere comparable with Git, right? So we have only uh, one version management system, which is like open source also. It's like a heaven for developers actually. So to interact technical code interaction, collaboration, and all those things are seamless with GitHub, right? Nowadays everybody is using GitHub. So similarly, it is a must for any engineer, any software engineer, including DevOps engineer. So we need to learn about Git as much as possible, and basic fundamentals of Git are a must for any engineer. So we will try to cover GitHub also now. We'll try to cover uh, the basic how actually the Git works, how what are the different what are the different fundamentals of Git, how it is working, and we'll discuss about it. Okay. Yep. Yep. So as I already discussed, few people who I think everybody knows about like how CloudX Lab works. So we use Jupyter. So Jupyter is an online ID for us. So we can do the same thing what we can do in our computer. We can do the same thing in using Jupyter. So everybody can have, who has subscribed to our course, has their own Jupyter ID. They can work on it actually. So in last time we already discussed how to create a Python script, how to work on Python scripts using Jupyter. I think everybody has done their homework also. Like we had a Python related project to build based on file system, right? So we how to read a file, how to read the lines from a file. We already have that course. People who haven't done it, please go through it again. It will put yourself in hands-on, make yourself comfortable in Python language, and it is like a helping session. It will give you immediate feedback of whether your program is correct or not. So it will help you to make yourself syntactically and logically perfect in terms of Python coding. So please go through the course. We already have completed the Python course. Please complete that course if you haven't completed it. Yep. Yeah, so we'll go through Git. We'll go through Git as a separate session. We'll go through how to use Git. We will be having a bit of hands-on on Git also. How we to create a repository, what is Git, what is GitHub, and so on. And what are the different basic commands that we use in Git, which I think we already know, but we'll just have a quick overview. Yeah. Okay. Yep. So yeah, so these are the different phases. Like till now we have divided into dev and ops, and now we discussed about devs and their related tools. We'll be having a discussion about operation and the related tools. Like most of us, I think, might be more interested in operation related tools. That's where the real power of DevOps comes. I don't mean like in the dev there are less tools. They are also equivalently powerful, but these are the tools which generally software engineers don't come into in the daily basis. Like these, for operation point of view, what tools generally people use, DevOps people use those tools which general developers are not used to work on them. They generally focus on the real business feature, right? So when it comes to DevOps engineer, they're morely focused on the infrastructure management, how to make the build process and so on. That is what the DevOps engineer actually does focus on. So to build like DevOps use nowadays like Maven and Ant is old. Like there, no, I don't think nobody new developers like if a new company, new startup company comes, nobody use Ants, but Maven, Gradle, these are the famous tools that people are using nowadays. Um, so Maven has its own ecosystem. There are a lot of packages and builds already in the what you call it as artifacts. Artifacts basically they are libraries which are available in Maven repository, which is called Maven repository. You can just download from anywhere and use those particular libraries as dependencies in your project instead of rewriting the entire code, right? And Maven provides a very clean way of how to build any kind of project, whether it is Java project, whether it is Golang project. You create a Maven task. So making a Maven build, and you actually say the Maven saying that it is a Java kind of project. You actually introduce it, and the build comments are common for any kind of project that you build. So for to building Java project or whether you're building Golang project, you can just use the same command for Maven, like Maven build, Maven test, based upon the task that you actually define in your Maven, uh, what you call as POM XML. We can discuss more about it afterwards. It's a process of build. So here the point is like as a part of build, DevOps engineer needs to know about a few of the build tools which he might be interested in order to build any kind of application which developers build, right? Yeah, so this is build. Like test as a part of continuous integration. You have to enable a very robust test infrastructure. It is not just unit test which developer build. There are a huge set of other tests also. You might have seen manual testing is what they say, but nowadays unit testing, integration testing, stress testing. So there are many other kind of test environments that are being built to test your particular application, right? So to test a small feature, you have unit testing to integrate a new feature into existing so you actually, when you integrate multiple features which are developed independently, then there comes integration testing. When you want to actually test on the the like stress testing, there are many other kind of testing also. So for each and every testing, you need to have a proper testing tools enabled, and those tools should be integrated along with the continuous integration process. As a part of continuous integration process, these testing frameworks should also be enabled. Of course, right, they are not independent. Like Maven, in the Maven itself, you actually provide the test environment also. What are the testing libraries that you are going to use? They are interrelated. Like in the Maven itself, you have to say what test tools you are actually using. If it is a Java, for example, if you are building a Java project, you actually use JUnit tests, right? That you actually integrate in your Maven build process. Okay. Yeah. So other things, right? Already have discussed as a quick overview. You can actually again recollect what we have said as a part of release cycle. What is actually release cycle of where? So after your testing, coding, building, everything is done, then the main thing comes. It's the release process, right? So you release.
Anil, can you move this into show mode, slide mode?
Okay.
Too small to.
Okay. Slide mode. Okay. I think where shall I do? Do you know how to do it?
You can just click
Anil,
button.
there is one, right side there is one button, right? Arrow mark.
Mhm.
Will it work? Yeah, that one.
Okay. Nothing happened actually.
No. in the PDF, right? There is an arrow marker.
Yeah,
If
if
you
you
are
click
going
that,
to,
it will open in a new browser. Yes.
you are going through the document, right?
Okay. Okay.
Yes.
Yeah, maybe I will zoom it. Yeah. Okay, so it was not visible for you guys, huh? I think now it is visible to you, right?
Yep. Thank you.
Okay, great, great. Okay, so here you have the slides already available. So I will actually this is what the main what we are actually discussing as a part of DevOps engineering. So the basic concept what I actually already introduced is like every as a software development cycle. These you can see, but typically focusing in DevOps point of view, these are all the phases that you actually see when as a DevOps engineer, right? So in each and every part, DevOps plays his own role, right? So planning, coding, building, testing, release, deploy, operate, and monitor, right? So these are the different phases that actually DevOps engineer goes through, and in each and every phase we actually use specific tools, right? So we actually discussed the same things now. So just for planning, what the tools we use, for coding, what the tools we use, for building, what the tools we use. So basically, like I think most of us may not cover all the things, but for giving a general idea, we need to cover each and everything, right? So like planning for designing a software and all those things, we use tools like Microsoft PowerPoint, Microsoft Docs, Microsoft Google Sheets, Google Docs, and so on. For coding purpose, we use our favorite IDs, integrated development environment. So I already said that nowadays I would actually strongly recommend. I think it will fit for each and every one of you. You can actually use Visual Studio Code when you actually code any kind of programming language. I am pretty sure that it supports any programming language, whether it is Java, whether it is Golang, whether it is Python, or any language, right? You have Visual Studio Code, it is all rounder. You just download Visual Studio Code one time and you develop your code in any language. I just show you that Visual Studio Code. This is our Visual Studio Code, and this I think I'm building a React application here, right? So it is also helps us in React application development. So this is one example of React application code. For this, you have to just add React specific JavaScript specific extensions. So Visual Studio Code is very intelligent. By looking into the code itself, it will automatically recommend you, saying that okay, it looks like a React application. You need to download this particular extension. All you need to do is install those applications, right? So that is the beauty of Visual Studio Code. So like so this is an example of Java code that I am building in Visual Studio Code itself. It automatically identifies that this is a Java code, and it actually provides you feedback when you actually code. It automatically finds, like, it gives you suggestions also, what are you going to type in the future. So it automatically gives you suggestions also. So this is a very proper, very mature tool, very mature ID. You can use it for any kind of language development. I would recommend everybody to put yourself very much familiar with this particular ID, Visual Studio Code. Otherwise, you are free to, if you are only Java coder, then you can actually go with IntelliJ, Eclipse, and so on. Nowadays, I think nobody uses Eclipse. I would say no to Eclipse, because Eclipse is very heavy, very heavy. Unless you find it like you are a very keen user of Eclipse, I would not recommend to use Eclipse. Um, but this is a very light. I wanted to summarize is, like, Visual Studio Code is very light application. You can open multiple projects at the same time in different windows. You have seen, like, Java code I am doing in this one particular window, and in this particular window I am using React application. I'm developing React application. Tomorrow I can open Golang application. Here I'm using Open API project. I am creating an Open API project. This is the beauty of Visual Studio Code. Okay, let's go to next topic. Um, so we can do wonders using Visual Studio Code. That's what I wanted to say. Okay, so as a part of coding, that comes a powerful tool, Visual Studio Code, and afterwards build. So when it comes to build, I have just given a brief overview of what is the famous build process. I am very much used to Maven, Gradle. I have worked on Gradle also. So and is also build tool, but I think nobody uses it nowadays. So when it comes to build tools, these are now Python also. Few people actually build using Python coding. They use their own Python build process, build their own build system using Python language. So we can also build using proprietary Python language. So that is what build helps for. Yeah. So let me go up. Okay. So we were discussing about different cycles of DevOps. What are the advantages? What are the benefits that we are getting using DevOps? You might already seen that by my statements. You might already found that DevOps has made the delivery reliability, scalability, and speed to come to the next level right now. So things that were before, like a few years back, how the development was happening by introduction of DevOps, how the things are happening now are like completely uncomparable, what we can say. Before, which used to take weeks and months, now it happens within days, within 1 day, 2 days. So we can count like next day. You may not be surprised because of this DevOps tools. You just ship your product in the next day itself. You can do that. You can do that actually. Yeah, so these are benefits of DevOps tools, and we were actually discussing different phases, right? So we were in this particular phase, and we also said that we are nowadays, everyone has who is supposed to work on software should know what Git is, right? What is Git? What is the basic? We'll cover about what is the fundamentals of Git, what is the architecture of Git, how Git works, how to get yourself. What is the general practices a particular typical team in software development follows in using the Git repository, how it makes your life easier. We will actually discuss about it. Basically, Git, you already know, you all guys are experienced engineers. So basically, it is a version control system, and people who are 15 years experience guys might be wonder, might be actually able to admire the beauty of Git, right? People who have already used, I think, we have already used other code source control like SVN, might be they might have already used them, and now by using Git you might be able to see the difference, right? How Git is actually solving the real-time problem of version control system, right? We'll go through the Git as a separate session now today only. Yeah. Yeah, so testing, release cycle we have covered. Yeah, so deploy. So as a part of this cycle, we have seen release, and we came to deploy, right? Deploy, everybody can't be expert in everything. We will give a brief overview of for the deployment process. We use these tools. Just keep it in your mind. For deployment, we use Puppet, Chef, Ansible, and SaltStack. Out of which, Ansible is more famous nowadays. Ansible is more famous because of few reasons. Yeah.
How do you differentiate between release and deploy?
Release is in the sense like you build an artifact. Okay, so as a part of build process, after test is done, everything, you create a binary, right? Create a binary, you create an artifact, what you call artifact, and you put it in a centralized repository. If you want to
Nasus or artifactory kind of thing, is it?
Yes. If you like, Maven has this repository, right? So it's basically a release, right? You are not deploying. You just put it in Maven. You build your own library and you just release it into Maven and say that, okay, it is available for everyone. You can download it and you can actually use it for your own purpose, which is called deployment, right?
And
Yeah.
it's not part of Git family.
Release can be part of Git family also. Nowadays, every tech stack has his own version of release, right? So Git has its own version of release also. So people have an option. If they want to have their own release management system completely based on Git only, they can use that also. So we have something called release tab somewhere in github.com. That you can actually see what are the releases are. When you actually release, right, in GitHub, there is something called the tags. So generally people, when you actually finally build and you are done with your complete build, you particular tag a particular commit. So, in Git, do you have different commits, right? So in when you use Git kind of release practices, what generally you do is like you say that, okay, this commit, I will tag it with particular version, this particular version. So that means that you are releasing this particular commit as a production ready build or something like that. That is how generally people in industry actually do. They use the concept of tagging concept for release purpose in GitHub. If you use GitHub.
Okay. All right. Yeah. Thank you.
Okay. So just have a look into, just type in Google GitHub tags where it is used. You will get the answer. So GitHub tags, generally they are used for release cycles. Okay. Yep. Yeah. So similarly, like for deploying, we are using these tools. We can't cover all these tools, but I would actually cover Ansible. Ansible is a very beautiful tool. Like it actually helps automation of deployment into many multiple machines without the requirement of installing the Ansible in that particular machine. So that's what it actually um, um, keeps itself away from other kind of deployment tools, right? So here Ansible, the power of Ansible is that you need not deploy anything Ansible specific software in the machine where you need to deploy. All you need to do is you need to have an Ansible machine in your machine, and you need to have a access to the remote machines, production machines, and you can actually deploy that. So that's the way.
Anil,
Yeah.
so for deploying the solution, can we able to deploy in the cloud as well?
Yeah, we can.
Okay.
Yeah,
So by using this tool, we can able to deploy in the cloud as well.
Yes. Yeah. So basically, so if you talk about any cloud, for example, AWS, in AWS, we can have multiple EC2 instances, right? So what happens is like, you can actually make one of the EC2 instances. Suppose you want to deploy in 5 EC2 instances. Okay. So you make you create a separate EC2 instance within the network. I'm saying, for example, you create a one EC2 instance, there you install Ansible. So it is like a deploying machine. So deploying machine for you, build a machine for you. From there, once you install Ansible, you can actually deploy into other EC2 instances, different applications, whatever you want to actually deploy, whether it is applications, whether you want to install software. Suppose you are having EC2 instances, multiple EC2 instances in AWS, EC2 instances, and all are Ubuntu based. For example, just I'm saying they are Ubuntu based. Well, you might want to upgrade the software, right? You want to execute simple software upgradation like apt update, apt update. You can just do apt update on all those machines using Ansible tool. You can just write a simple what you call YML. So which is called playbook, which is called playbook in Ansible. You write a playbook and you just give that host IP addresses, EC2 instances IP address, and you are ready to go with installing or deploying any kind of application. So we will go through it. We will have a hands-on of how to use Ansible. We'll have it's a very simple tool. We don't want to, we can write a very big complicated application, but for demo purpose, we will write a simple tool. Probably I'll try to do it in a cloud machine only. I will give you a demo of how to use Ansible in cloud machine. Okay. So similarly, like Docker is a buzzword nowadays. We will go through it. What is Docker? Kubernetes are also like we are being used very much nowadays. Every big players are actually having their own Kubernetes managed solutions. Like if it is Azure, they came up with a product called AKS, Azure Kubernetes Solutions. If it is Amazon, they come up with EKS, which is called Elastic Kubernetes Solutions or something like that. So AKS, IBM have IKS, IBM Kubernetes Solution. So AKS, EKS, they have their own version. So Kubernetes is a buzzword nowadays. Now many people, we will have some, we will actually have a separate session for Kubernetes. We'll discuss about what is Kubernetes, how it is solving the real-time problem, how is it is helping us in enabling microservice architecture, how it is helping us in self-healing model. You need not have any human interaction. It actually recovers itself from any failure. So how it is doing that, we'll actually have a discussion in the next upcoming session. So nowadays, these are the most commonly used tools as a part of deploy nowadays, right? Yeah. So you might have heard about cloud native enabled. They claim, many companies claim that we are cloud native. So what they actually mean is like they are using container based solutions, they are using Docker, they are using Kubernetes. So that's the way they that the word comes there actually. Cloud native, we are cloud native enabled. That means they are using Dockerized solutions, containerized solutions. Okay. Yeah. Yeah. So like just we are going to describe about other things like operating. How do we operate? So once you are in production, you should be able to operate the existing software infrastructure in effective way. Similarly, monitoring, right? Monitoring. We have many monitoring tools that we actually use, out of which mostly used nowadays is Grafana. I'm not sure. I haven't much touched in monitoring part, but in my 15 years of experience, there were monitoring tools being used, but they were deprecated and they are no longer being used. Now Grafana came into picture. Then if you are using Kubernetes, then Prometheus comes into picture. Prometheus is a separate monitoring tool, which is very strong, very powerful. I hope it lives a longer life. I think it will live for a few years at least, for sure. So these are the monitoring tools which we will cover in this session. Okay, in the upcoming session. Okay. Yeah, so this is a very important slide. We need to keep in our mind, which a typical DevOps, which comes under typical DevOps practices, right? Already discussed the entire the entire DevOps process. What is the basic idea of DevOps process, and we can actually relate them with these followings. Okay, so basically continuous integration I already discussed. Feel free to ask if you are not clear. I'm sure you all are experienced guys, you know about like continuous integration, continuous delivery, and microservices is a new solution for the real-time problems that we have been facing for big industries since long time. So nowadays everyone is actually designing, implementing solutions in a microservices way. So basically, in simple terms, you can say that it has solved by using microservices architecture, it has solved the scalability, reliability, and um, all the required fundamentals of a perfect software. Microservices has solved to some extent. It has solved to some extent. It has made it flexible for us, basically. So like you, if so the opposite of it, we can say it as like monolithic. In before we used to have something called monolithic application, a big application, a single one, only one application, very big application where all the features were there. So before, the development was something like that. Entire application was in as a single application and used to deploy the entire application has a big giant, right? So it had problems of its own. So what if like few people are using only one feature, few people are not using some features at all, like few features of the applications are used by billions of users, but few features are being used, are not used, are very rarely used, right? And so those problems could not be addressed by a monolithic application. So, and maintainability of a monolithic application, if you want to change a single line of code, you have to deploy the entire application again, right? So that's a real what do you call real problem when it comes to adding a simple changes. It becomes a really very hard work and effort oriented, right? So those also problems have been solved by microservices architecture. So basically, in single word, what microservice architecture is like, you divide the entire application, entire what you call application can be looked at as a big problem, right? You divide the entire problem into very small disjoint problems. So you develop applications, small miniature applications independently. Independently, you deploy them independently, you maintain them independently. So it is easily scalable. It should be designed in such a way that they interact with each other seamlessly, and they could actually easily scale, easily upgrade independently, right? So that's the basic idea of the microservices architecture. And nowadays, every DevOps engineer is supposed to have microservices fundamentals in their mind, because when they come to real-time production, when they are on call, it is self understood that DevOps know that it is not a single application he is going to tackle with. He is going to tackle with small microservices applications which are already working in production, right? So that is the basic idea every DevOps engineer needs to have in their mind. Okay. Yeah. So we are already having this microservices architecture, right? So already I said like simple single application as a small services and so on, right? So each service communicates with other services through lightweight mechanism. So we can say that big application is divided into smaller applications, and they can be communicated, for example, via REST API. They need not connect only via REST API. They can connect via RMIs, they can connect via RPC calls, in any ways, right? Based upon the technology that you're using. So basic idea is like divide the entire application into smaller applications and seamlessly talk to each other, integrate with each other, so that they can develop independently. They can be deployed independently. They can be version controlled independently. So that's basic idea of having a microservices based architecture, right? So it can also be scalable. Suppose today you have only 5 microservices. Tomorrow you want to add a new feature, you just add a new microservice. Basically, it becomes like you have now 6 microservices. So it is as easy as that. You can just add a new application to the already existing application. So it solves the problem of what you call you might be heard about these buzzwords like horizontal scaling, vertical scaling. So basically, it actually helps us in scaling, horizontal scaling in this case, right?
So Anil, each individual microservices, are they container in itself, containerized application, or?
Yeah. So how microservices are implemented? One way is by container itself, right? So microservices is basically a concept, right? Microservices is basically a concept. The concept behind it is like solve the problem in a divide and rule way. So divide into multiple. In your case, we can implement the microservices using containers, but that is not the only mandatory way, right? Few people might want to say that I don't want to use a container-based solution at all, but I want microservices concept. Yeah, so basically microservices is a concept. Yeah, and your question is right. Basically, nowadays, most of them are actually implementing microservices using container, and each and every container is supposed to be having a microservice. Yeah. So in this case, like for example, you have Docker container, a particular Docker container, a microservice application will be running inside the Docker container. And similarly, if you have 5 microservices, you can actually opt for having 5 containers in which 5 small microservice applications are running inside each and every container. But it is not like a Docker can actually run multiple container also, but it actually defeats the purpose. For simplicity purpose, generally people install only one application, one microservice application only inside a container. Yeah, and microservices is basically a concept. Microservices is basically a concept which is an answer to the problems that we are facing because of monolithic application. So in simple words, monolithic application is a very big application with all the features in it, right? Microservices can be looked as like small applications integrated together to form a big application. And how the microservices are implemented? They are generally in practice, most of the time are implemented using containers. We will show an example of that using Docker containers. Okay, yeah, so that's what the microservices is and what DevOps needs to understand what exactly the microservices is. Okay, now infrastructure as code. This is the new thing that has come, right? As I already said, right? If we are doing the same task every day, right? Better to automate it. So from there came this concept called infrastructure as code. Suppose imagine yourself as like you want to deploy a particular application. You want to order a particular machine with some few 4 GB of RAM, this much amount of hard disk, and with that network, what kind of network you want to expose, whether it is a VLAN, it should be inside VLAN, or it should be external, should it export few ports, what export it should actually block. You have set of instructions with you, right? So you are doing it every day. You can do it every day manually, going to your machine, going inside your Ubuntu machine, enable the UFW firewall, and you can actually add hard disk to it and so on, right? So all these things can be automated. So instead of doing this manually, what you do is like you just write a simple code. You write a simple code, configuration code. Basically, we'll show a Terraform example. Basically, a YAML which says what kind of infrastructure you are ideally want. What kind of infrastructure you ideally want. So once you write that particular code, you need not think again. You need not put your effort again and again. You just run that code in multiple times. Every time you run that code, you create a new machine. So you actually configure your new machine. If you already have an existing machine, you want to make a simple changes in that particular machine, you just change your code. Instead of 8 GB, you can say I want 10 GB of RAM. If you want 16 GB of RAM, you just change that particular value in your YML and rerun that particular code. In your existing machine will adjust itself automatically. So that's the main concept. So instead of you remembering all the commands to actually manage your infrastructure, you just write one time as a code, which is called infrastructure as code, and run it at your need, right? You can just forget it and take care of the infrastructure of code specific services or specific tools will take care of everything, right? So that's the main, that's the new thing that has come up, which has made the life of managing all the infrastructure very easily. So using this infrastructure course, people are actually are also using user roles, groups management, all other things also, right? Like this, any typical application will have its own authorization, authentication. So those can also be actually, there's also comes as the infrastructure, right? So we can use the same infrastructure as code concept to actually help us in managing authorization, authentication as well. So this is a new thing that has come into picture. Infrastructure as code, and the basic tool which we are nowadays being used very hugely is like a Terraform. You might have heard about Terraform. So that tool is being used everywhere nowadays, and we'll go through it. We'll have a separate session for Terraform, how Terraform actually solves the problem, and using a simple Terraform code, how can you actually work on it is supported by all cloud providers. Like you can actually run your Terraform scripts for Azure. The YML file that you create is different for different cloud providers. So Terraform has some concept called providers. So in the providers, you have to say you are building a Terraform for Azure, or whether you're building a Terraform for AWS, or whether you are building a Terraform from Google Cloud or something like that, right? So that way, actually, you write a single YML and you can actually manage your infrastructure, whether it is number of EC2 instances in AWS, or whether number of resources in your GCP. You can manage it as per your requirement in any kind of cloud providers. So write once and use it many times is the concept. Infrastructure of code is important thing. Similar thing. Yeah. So we already covered this. Yeah, so here what I already said you, right? So infrastructure code, we just have to write a simple YML configuration YML, and you are ready to go with you creating your own infrastructure, whether it is in staging, whether it is in production or testing environment. You just write a single config file and you execute this particular config file. Your infrastructure is ready as per the environment you are building. So yeah. So monitoring, once your code is in application, it is a very much is very much mandatory process to actually have a monitoring metrics and logging all the, whether it is the application's status, but the application health or your customer statistics or anything, right? You need to have a monitoring metrics, right? So this is a part and parcel of, like, you need to have a specific monitoring tool as a DevOps engineer to be deployed, to be how you need to learn how the different monitoring tool works. How do you log? How can you actually manage the log in such a way that at real time you can actually find the root causes of any problem that comes in a very easy way, right? So monitoring tools actually helps us in doing that. Yeah. So collaboration. So like DevOps engineering also, like how DevOps process actually helps in collaborating in a proper way. So we don't have any specific tools in this particular course for collaboration, but general idea is like we generally use many of the tools, right, for like Slack and so on, right? It is self-intuitive, we don't need a separate session for it, but we have a few collaboration tools which DevOps engineers are also supposed to use in order to collaborate across team and communicate uh, as a part of as a part of their daily practice, daily roles, right? So this is also part of a DevOps practice. Collaboration is also part of it. Okay. Yeah. Okay. So just go through this particular slide, and this will help you understand what are the essentials of a DevOps engineer. I would actually recommend always keep this particular cycle in your mind, and for each and every cycle, what tools are being used, that will be helpful for you. So this cycle will help you, like for coding, what are the tools used, for planning, what are the tools used, for deployment, what are the tools used, for monitoring, what are the tools used. So just keep this particular cycle in your mind, what are the tools being used. From there you get deeper and deeper. So how to use that particular tool, how to become expert in that particular tool, we'll go one by one. Yeah, so these slides are very useful, and this slide is also help you if you want to recollect. Just keep this slide and that top slide in your mind. It will help you to recollect things in a very constructive way, constructive fast way. Okay. Okay. Now we know, like, I suppose we all know what exactly DevOps engineer is supposed to be. What are the general concepts DevOps engineers needs to know? What are the main phases? What are the main phases in software cycle, and what is the role of DevOps engineer in different phases, right? What are the basic DevOps practices a typical DevOps engineer does? We all know about it, right? So please actually have a look into it. Go through the slides once again, and that should be enough for you. And on the upcoming sessions, we'll be having hands-on. We'll be showing how each and every practices are being practically implemented by a DevOps engineer. We'll go through that. Okay. All right. So we have covered the DevOps session now. We'll go to the next session. Okay. So the next session is, I suppose we'll go through quickly about Git. Okay. Git, okay. All right, now DevOps is over. Now let's go to the next. So just try to answer all these questions. Um, Okay, so how about answering these questions? Please, I think I'm sure right afterwards you get into your own world. Why don't you spend some 5 minutes of your time, try to answer these questions and try to see what is the correct answer. So I will pause for 5 minutes. So I'll get back after 9:12 to 9, maybe like after 9:15 I'll come back. Just try to answer these questions related to DevOps and see how it goes. Okay. So there are like 27, there are up to 27 questions. Please try to answer these questions. So I will pause for 5 minutes. Please go through these questions, try to answer them and remember them. I hope everybody has opened their courses right in their own browser. Please spend some 5 minutes of your time to go through these questions and try to answer them. Okay, welcome back. So let's start from Git. Let's start into Git again. Okay, so we everybody of us I think know about Git. Um, it's the only one, as far as I know, used version control. Unless few companies have their own proprietary version control system, few companies might be having, but generally nowadays everybody is using Git repositories everywhere, right? So we'll just start with what is Git, how it is actually helping in collaborating the code, collaborating with other tools in a to actually enable the entire software development cycle in a reliable way. Yeah. So So we'll actually briefly overview, like you might be knowing, right, what is Git. Basically, right, Git was actually developed only developed, I think, by Linus Torvald for actually managing the Linux source code. Later, it became open source and started evolving, and many people started contributing public repository, contributing their storing their own repositories, public repositories in GitHub, right? So that's the way the Git evolved itself, right? Um, Yeah, so what actually the Git is supposed to solve, right? Basically, what is the source code control management? We have a lot of theory of what exactly. So feel free to read them. So basically, control management system, what is supposed to do, what is its main purpose? Main purpose is like there are few bulleted points here. So basically, source control management system is supposed to allow multiple developers work on the same code. Like you might all know that, right? So just to emphasize the main concept, we just bulleted them. We want to just recollect what exactly the Git solves, right? So basically, it allows multiple developers work on the same code for different features. You should be able to undo the changes. If you have made a changes, you should be able to revert them. If you feel like you did the wrong thing, you might want to undo them. So you want to actually manage, like uh, you want to divide and load the work to different developers, right? So that's the way how to load the work between developers, how to resolve conflicting changes, because multiple team members are working on the same source code, right? How to actually resolve if there are any conflicts in the code, if the same line uh, has different code by different developers, how to resolve the conflicts. So these are the typical problems a typical SVN source code management actually solves. The same solves, right? So why do we need a version control? Why do we need version control, right? So these are the things why we need version controls. You might actually find it like a backup restore, so that if it is in your if it is in your own system, then it is not available to everyone else, right? And it is a centralized repository which can be looked as a backup and a restore. You at any point of time, if it is lost in your personal machine, you can always get it back from the backup, right? So synchronization, as the word says, synchronization, how to share files between developers so that they can continue develop and work on the same updated code, right? How to enable synchronization, and how to do different kind of undos, short-term undos or long-term undos, how to do that, and how to track the changes, how to track history of a file, what the file was few days back, how the file was few months back, right? So how to track the changes, how to track the ownership, who created this, who committed the changes, and so on. And sandboxing, right? Make microservice development test changes in a controlled area. Okay, so that also is important thing, right? So you want to sandbox one particular feature only in its own isolated area, right? So that concept can also be enabled using, that should be enabled using version control. And branching, merging, these, I think, if who are using GitHub might be knowing what exactly we are talking about, branching and merging. So basically, you actually, different people work or want to finally come up with a single code, but they want to work in an independent way. So you can actually create a separate branch. You should be able to create a separate branch, work on your own feature, and then later, once you feel comfortable that you are done, you can actually merge the entire feature into the main code, right? So that is branching, merging. So these are all what exactly the version control solves, which is the basic fundamentals of any kind of software, any software development team actually requires, right? So these all are the things which actually a typical software engineer requires. So this is what so version control wants, and Git has solved all of them, mostly in a more matured way than source control source control management tools, right? Now Git is like the most matured version control system, and it solves all these problems, right? So see, it solves it's in its own way, other than old version controllers like Bitkeeper and all the other code tools are right now outdated. Um, so how actually Git actually works, right? How that is most important, right? How actually design, what is the design between, what is the design principle between GitHub, right? So so the design goals of GitHub, like when it was evolved, these were the main fundamental things that were kept in their mind, right? So they wanted a very speed system. It should not actually be a bottleneck for the actual development process. So that was the main idea behind, that was the main goal, goal behind, one of the goals behind developing the Git system. So they always kept speed in their mind. They kept the support for non-linear development also. So we can non-linear development in the sense, like you can see, like you can have thousands of parallel branches, and still it is stable. And you can actually work on thousands of parallel branches, and you should be able to merge them all together into main branch. So that is what non-linear development is, and it is fully distributed. And it is it was actually developed for Linux kernel development. The history of Git is like Git was mainly actually developed only to keep the Linux source code first. Afterwards, it's actually later it was made open source, and it was open to the world, to other repositories. Before, it was actually the main design goal of Git was to handle the Linux kernel project. Yeah. Yeah. So as I already said, please have a look into this. So these are the basically the main problems, the main problems that this version control are supposed to solve, and Git has solved them in its own way. So how GitHub actually works, right? How the GitHub works, right? So basically, the how GitHub works is, as you might already be knowing, you just need to install. It is supported across all software operating systems. So you need to download your OS compatible download and install it, right? So this is the centralized repository from where you actually download your GitHub tool and install it in your machine, whether it is Windows, whether it is Linux, so Ubuntu, any kind of OS, so Mac. You can just download it and install it. Once you install it, you can create your own GitHub account. So like there are other variants, paid versions also, like GitLab and Bitbucket are also there, which are a little bit of variant, which internally runs the same GitHub server there. So you just need to sign up for your account in GitHub. It is free, and they also have a paid version also for business purpose. You sign up, and then you are provided with a GitHub account. Once you have a GitHub account, you can actually work on your source code by creating something called repositories, right? So for your source code will be in a repositories. Generally, by default, you can create as many public repositories as possible. So I'm just I suppose everybody knows about public repository and private repositories. I'm just keeping it out. Please let me know if you want clarity. I think everybody knows about it. So GitHub, actually we have we have something called public repositories, and so it's a fine tool, like it, as you know, right? Once you install GitHub, it has a huge ecosystem. Many volunteers actually come up with their own client versions, GUI versions of client versions of GitHub for managing the source code. You can just download anything like GitHub extension, source control, source tree. There are many other client tools. You can just download them and use them, or you can use the CLI tool. Most of us actually must be knowing about how to work on Git using command line interface, which is called CLI. you can you have to learn the basics for sure, right? Yeah. So there are set of commands, like there are few like 5 to 10 commands that should be enough for you to start with Git and try to understand. You need to have a concept of basic concepts of understand fundamentals of Git, how the GitHub works, and about 5 to 6 commands how to use the Git tool for your source code management, and you are good to go. Okay. So as a process of as a part of it, like after installation, all you need to know like how are you going to work on your specific repository. Repository in GitHub is nothing but a place where all your source code belonging to a specific application that you are building resides, right? So that is called repository. So a repository can be shared among multiple people who are belonging to the same team, who are actually willing to contribute on your source code, right? So that is called collaborators, right? So in GitHub we call collaborators, right? The entire team will be coming under collaborators. So once you are a collaborator of a particular repository, you can actually use you can actually use the code with different access rights. I will go through them later. Just to overview, right? Few people can have only read only, view only access. Few people can have read write access, and so on. So that is how GitHub works. I just show you. I'm sure people know about it. I'll go. So this is one GitHub repository, a sample example of GitHub repository. So here you have different tabs, right? Each and every tabs have their own purposes. So here you can see the code section where you can see the entire code or what you have written. In this particular example, I have written a Python script. So this is the Python script. You can see the source code. You can have multiple code. Like here we have four files actually, and one hidden file, git ignore. Yeah, so once you can actually have, this is an example of how to actually view your repository from the browser using github.com website. Once you can create your website, it is straightforward. You have to give your email address and password, and you should be good to go. I have already logged in, but if you are not logged in, once you type github.com, you should be coming up with a sign in or sign up page. You should be able to come into sign in page. Because I'm already signed in. You will be directly coming to your home page of GitHub. But if you are not sending it, you just just provide your email and a few fundamental information, and you are good to go to create a GitHub account. Once you create a GitHub account, you are ready to create your own repositories, right? So this is one example of already created repositories, which is already uploaded in GitHub. Okay, now back to the slides. So I have shown you an example of GitHub, and if you already have a repository, how do you actually download the repository into your local machine? So the process of downloading the local repository from the server to the local machine is done via command, something called git clone. So this is an example of, this is command of how to download a repository, right? So git clone, and this is the SSH way of getting the clone. And this particular repository URL, you get it from here. Here there is a code button. On click on this code button, you have different variants of how you can download. You can download it via HTTPS way. This is HTTP way. Or you can download it via SSH way. This is SSH way. So using SSH way, generally people actually prefer, GitHub also prefers you to actually download it using SSH way. So you can download it using this particular URL and download it, right? To create this particular SSH way of downloading the repository, what you need to do is you have to generate a SSH key. You have to generate a SSH key and add it to as a public key. Add the public key in your GitHub account. So this is SSH key password, which I directly got it by clicking here, right? You can actually go by clicking on settings. by clicking on settings, and here you can actually go SSH key. Here is a SSH key. You can actually copy your local machine SSH key and copy it here. So these steps is a fundamental thing when you want to actually work on your repository, clone your repository, and you have to commit your repository using SSH key. This is a fundamental thing that you need to know. Okay. Now, how to create SSH key? You have to create your SSH key via SSH key command in your machine. So in your machine, if you are in a terminal, whether you are Windows machine, you have to use openssl tool. Whether you are in a Mac, you can use the openssl tool. So openssl tool comes as default in Mac. So you can actually type the command SSH key gen. This is a command to actually generate SSH key. So so using that command, I think in the slides already I mentioned so this is the command to actually create your SSH key in your local machine. So it is always recommended to use 4096 as bit key. And this particular command will help you to create a local SSH key in your machine. Once you have executed this particular command, right? Once you executed this command, a public key and private key combination will be created in your home directory. In your home directory, there will be a hidden directory. I can execute it here. If you are familiar with Linux commands, you can list all the you can list. I think it is not visible to you properly. Let me try to increase the font. I should be able to increase the font somehow. Okay, I'm not able to find. Okay. Okay, to actually execute this command, right? Okay, let me expand this. So to clone a repository, in order to clone a repository, you have to actually generate your own SSH key. In order to generate your own SSH key, you have to execute this particular command. So once you execute this particular command in your local machine, automatically a public key, private key, RC key pair will be generated for you. So it asks you to where you want to store. Just enter the default location. The default location is in your home directory. There should be a folder, a hidden folder called .ssh. In that .ssh, that particular key will be already be created. I think I already have a SSH key, so I don't want to override it. I'll skip this step. So all you need to do is to type this particular command SSH key, and you will be having a folder called .ssh, which you can see minus a. So ls-a will give you the folder name, right? This is the folder name. So you can see the contents of it. You can see contents of it by typing .ssh. You can just access, you can ls in it. Once you ls on it, you see that you already have a folder called IDRSA. You can ls on it. Okay, so you have a public and private key, right? So this is IDRSA. IDRSA is the private key, and IDRSA .pub is a public key. So this public key, what you have, I think that public key, you need to copy it in your. You have to create that particular thing. You have to create that in a SSH key. So you by saying that new SSH key, you can actually add the existing key there. So you just copy the contents of your SSH key here. So you can open that particular contents by typing vim in, if it is Mac or any Linux based machine, you have vim editor. Using vim editor, you can actually open the contents. .ssh id are the same. So this is the contents that you see when you open the public key that you have already generated, right? So you just need to copy this particular file contents, copy this file contents, and once you copy this file contents here. So once you copy this file contents here and you save, you click on this add SSH key. Once you add this SSH key, you are good to go. Then you can actually clone your repository. You can actually clone your repositories by using the repository URL. I hope you understood the steps, right? So people have to only remember the commands. The commands are already there in the slide. Feel free to, if you forget the command, just always go to this particular slide. In this particular slide, just copy this particular command. Okay, SSH keygen. Using SSH keygen, what you can do is like you can generate a public key and private key pair. And public key private key pair. Once you have the public key private key pair, it will be stored in a hidden folder in your home directory, and you can always open your VM editor and see the contents of the files. You can see the contents of the files which are automatically generated using SSH keygen, and copy that particular copy the contents into the SSH key settings in your profile. In your profile, you have SSH key and GCP keys. There you need to copy here. Once you copy here and add SSH key, using SSH key, you can actually clone the repository. So that is the ideal way people actually in industry actually do. Other way of doing is like using HTTP. So using HTTP, all you need to remember is username and password. Once you have your username and password, you are good to go with cloning your repository. So that is the other way. Generally, few companies restrict using username password because it is specific to the particular user. Instead, they always recommend to use SSH key way of cloning the repository. So okay. Okay, let's go through this. Okay, so you have this particular place code where you actually can use either HTTPS or SSH to actually clone. So for simplicity, I'll just show you this one. I just keep, it is a public repository, so it will not ask me for any password. All I need is copy this particular URL and try to clone in I'll create a directory. To create a directory, I use mkdir. I will say cloudx git demo. Instead, I'll try to clone it. Then you can actually see that your entire source code is cloned in Whatspot. You can see the contents of it by doing ls Whatspot. So these are the files automatically downloaded, right? So this is the way you can actually clone. So there are other commands in GitHub, which is called GitHub init, GitHub remote add, and other commands are also there, using which you can actually create your own repository, add the repository to your credentials and so on. So we'll go through that. So those commands are also there. Just have a look into those commands as well. So how does Git actually work? How does Git, what are the basic difference between Git and other version control systems? So how does internal, I think people know about it, but this particular diagram gives a very clear view of how the Git internally actually works. So basically, when you are actually changing the code, right? When you are actually working on the code, when you're changing the code, that is actually called working directory. So this is called working directory where you actually change the code. Okay. So all your changes can be looked as if the changes will be visible under working directory section, right? And after that, you have to submit your code to the server, right? The server is residing here, which you can see in github.com. So in github.com, you should be able to see the repository here, right? All your changes, once it is there here, then it is supposed, then we can say that your changes are in the server. Before that, everything resides in your own local machine. In your local machine, there are different stages, what we call different stages. So one is the working directory, and another one is called staging. Yeah. So one is called working directory, other is called staging area, and the other thing is like git dot, which is like git directory, which is the main local directory, local repository, right? So these are the different three places which is local to your machine. So once you make changes, it is there in working directory, and if you want to move to the next section, you have to say that you have to stage all your changes to the staging area. And once you are in the staging area, then you can actually commit to your local repository via commit. So that is called committing your changes, right? So always remember, in Git there is not only single command to directly put it into your server. So for any code changes to go to your server, you have to first stage the changes. It will go to the staging area. Then you have to commit the changes, which it goes to the commit local directory, local Git repository. Once it goes to the local Git repository, from there you have to push your changes to the server. So that once you do that push command, it goes to the server. So basically, you can say that we have different commands for doing all these different things, right? So what we say, once you make your changes to move to a staging area, you do git add. So there is something called git add command. By doing git add, you stage your changes. After that, to put it into your local repository, commit it to your local repository, you execute the command git commit. So using git commit, you commit into your local repository. And after that, to move your changes from the local repository to the server, you do something called git push. So always remember, when you actually move the code changes to the server, you actually do three things. Mainly, there may be other things based upon the situation status of the GitHub, but general practice is any changes, you do a git add. After the git add, you do a git commit. After doing git commit, you do a git push for a change to go to the server. So these are the three changes that you do. Yeah. So that's what I have already mentioned here. Add, commit. These are the commit changes. So this diagram gives you the overall picture what you actually do. I think most of you are already doing this, executing these commands in your day-to-day basis. You can correlate them with this diagram, right? So in this diagram, what is happening, you can see, right? You are doing add, it is indexing as a stage change, and then commit, it is going into local repository. And once you push, it goes to the remote repository, which is your GitHub server. It goes to the repository. So this is one way, moving from your local machine to the server. What else do you need to do in order to bring the code from your server to the local repository? That you can visualize here. So if you want to bring the changes directly to your working space, you have to run the command git pull. But if you want to only change the metadata, fetch the changes that have done, metadata of the information, like what is the head position now and so on. Those information only if you want to fetch, then you do something called git fetch. And there is something command called git checkout, which fetches from your local repository to the working directory. So that is called git checkout. So git checkout, you might correlate, you already might be using these commands always. So you can correlate them here. So git checkout head actually fetches from the local repository. Git checkout git checkout basically git checkout, you can actually when it comes to branch, you can also mention the branch name also by using -b command, git checkout -b. There are a lot of commands which when you go deeper and deeper into GitHub, there are many commands that you can use actually, right? There is something called git diff. Basic git diff. There is a command called git diff. Basic idea of git diff is like you want to see the changes that you have done from the your local changes. If you want to see, like if you want to compare the changes from the repository with your changes, then you can just do git diff. That is the basic idea. And extra parameters can be given if you want to do a git diff head. It will compare with the head of your local repository. Git diff head. If you want to do a simple git diff, it will do from the index, whatever index you have mentioned, so on. So this will give a general idea of how a typical git works. Like so, now you get an idea, right? So there are different stages in the local machine itself. In the local machine itself, you can actually see that there is something called local repository. There is something called stage place, which is called index place, and there is something called working branch, right? So there are three places of the code where the code can actually reside. And based upon what you do, whether you do add, it goes to the staged area. If you do commit, it goes to the local repository area. And if you do push, it goes to the remote repository. So that is the basic idea, right? So this single diagram gives you overall picture of how a general git commit, git push pull actually works, right? So you get an idea of how it works, right? You can correlate it with your with the commands that you daily work on, daily use, right? You can correlate. You can have a it is good to know like how actually the git internally manages. Once you have this diagram in your mind, right? So if you have any conflicts, if you have any problem, facing some problem, whether it is conflict or whether it is any error coming up, your GitHub seems to be inconsistent stage, then this diagram will help you out how to resolve the problem, right? It will help you resolve the problem, and depending upon your state, you can execute the command appropriately, right? Whether you want to revert your changes, whether you want to reset your changes or something like that. Okay, there are many commands in Git, and Git also has evolved from time to time, and it has become more and more stable from time to time, and it has fixed its own bugs also as time went. Now, mostly we can say that it is very much stable. With the latest version, it is very stable, and all commands works perfectly. Yeah. Yeah. So here, as I already mentioned, luckily we already have a slide. Like Visual Studio has its own GitHub extension. So you can actually, you need not go to the terminal to actually use your Git. You can directly use, you can pull, push, commit, stage all your changes in Visual Studio only. So here, suppose this is a typical source code that maybe like you are working on. Then there is one section called source control here in Visual Studio Code. If you are opening your Visual Studio Code, if you have already installed Visual Studio Code, and if you have to install GitHub extensions. So to install GitHub extensions, all you need to do is like go to this extension section and install GitHub. So you just need to have git, type git, and you should be having your Git already installed. Okay, so this is what GitHub. GitHub is an extension which is already installed in my machine. You need to install GitHub extensions here. Once it is installed, then you should be able to see the source control button with Git enabled here. So what happens is like if you have any changes, for example, constant, you have made some changes. Suppose you have created you have made some changes here. So once you make these changes, you can see that here you can see what are all the changes you have already made. So this is a GitHub extension in Visual Studio Code. You click on this, then you make you can see your changes here. So you can compare the changes. You can say that, okay, this was the previous changes, a new line was added. So it is very clear coded. So it is very user friendly. You need not see that in terminal. In terminal, if you want to these changes, you can just always do that also. This change is basically let's suppose I go to the repository. So the changes that you have seen here, same changes you can actually see here also by saying git status. It will say what files have been changed. So you can see that there is one particular file called constants.java. It is changed, right? So it is changing, this constants.java is modified. So that is what I have shown you here in GitHub also. In Visual Studio Code also, you can see that there is only one file called constants.java. And you can see the changes, like what changes have been done. You can see here using GUI, right? One line has been added, right? So same thing you can see here also. You can see the changes by using git diff. By using git diff, you can see that, okay, there's a green color coded line, right? So this green color code with plus symbol says that this is the change that has happened in constants.java file. And this is the line that has been changed. The same thing you can see in Visual Studio also. And you can see that this is more understandable, like you can clearly see that, right? So in order to make this changes, in order to I see this is in the working directory. Now you want to stage the changes. In order to stage the changes, as I mentioned in the diagram, we have different phases, right? So okay, so we have different phases right here. Here working directory we have seen. We want to put it in staging area, right? So in order to put in staging area, we can do it by pressing this plus button. So this plus button in Visual Studio Code will actually stage it. It will put it in stage changes. The same thing, same plus what you do here. Once you do this plus button, you move the changes from changes to stage changes. Now the constants.java is in stage changes, right? Now same thing, I can actually revert back by just putting minus button here. It comes back to the changes actually. Same thing you can do it in terminal also. In terminal, you do it by doing git add, and that part you can give the complete file name, or you can just type dot. If you type dot also, it does the same thing. It actually stages all the changes under current directory and recursively in subdirectories and puts into the stage area. Now I did git add dot, right? You can verify the same thing in Visual Studio. It will go to the stage changes. So it already went to the stage changes, right? You can put back into the also. So you can see that you need not rely on terminal for doing these changes. The same changes you can do using Visual Studio Code. So now what you did, you stage the changes by pressing the plus button, and after you want to commit into a local repository by doing commit command by doing the commit. You are actually putting all your changes into local repository. In Visual Studio Code, you can just type the message before commit, by commit, and you press the tick symbol. So the tick symbol is somewhere here. This is the tick symbol. On hover it, you can see that commit pop-up is coming up. So on clicking on it, you just commit it. The same command you can do it in terminal by executing the command git commit. Git commit, add a message, -m and message. Yeah, so this is the command to actually commit to your local repository. So once you commit these changes, your changes goes into your local repository, and from there you can push it to your server using the command git push. So you can actually push your local repository changes. Generally, you can just type git push. Otherwise, you can say origin the means like your local repository name to master. So which is like your local repository name, and it is so GitHub push command is something like git push your local repository to the remote repository branch. So local repository is generally origin, and remote repository is generally master. So that way the changes goes to the master branch. If you put it master, it goes to master branch. Generally, you just type git push, it automatically identifies which branch it needs to push into based upon the branch which you are right now in. So GitHub has something called branch management. So we can have multiple branches in a Git, right? So you can see what are all the branches are there for this particular Git repository from the browser itself. In the browser, you can see. So for this example, What'sbot, you have only one branch main. But for example, if you have another, for example, I show an example of another repository. Here you can see that there are many branches, right? There is only one branch main. Well, other than that, there are many branches. You can create as many branches as many as you can. GitHub actually is scalable. You can parallelly work on thousands of branches for a particular repository. So these are all the branches. So if you want to see, currently you can see that your branch is main by the tick mark. Same thing you can look into in your terminal by typing the command called branch. So if you say git branch, you can see that, okay, now you are pointing to a branch called layers, whereas master branch, you are not pointing to the master branch, right? So that is what you are saying. So if you want to move to a different branch, all you do is git checkout and to that branch name. So if you want to move to branch master, you have to say git checkout master. So now you are checked back to master. So there are a lot of commands in GitHub, but you have to remember the main fundamental commands that you use in your daily basis. So branching is what a typical DevOps or a typical software engineer does in his daily life. He always works in a separate branch. It is always not recommended to make the changes directly into the main branch, because main branch is always viewed as a branch which goes to production, right? So for that, what we do is like we create separate branches. We move to that particular branch, work on that branch, make all the changes in that particular branch. Finally, once you feel that everything is stable, you merge that particular branch into master, right? So in order to move to a separate branch, this is what the command is like. Now I move to a branch called master. By typing git checkout master, I move to branch master. Now I can actually verify it by command git branch. By typing git branch, I can see that now I am pointing to master. I am pointing to master. If I want to move back to layers branch, I can just type git branch layers. By typing git branch layers, I actually move to layers actually. Sorry, the command is git checkout layers. By doing checkout, you actually move to branch called layers. So once you move to layers, now you can verify that you are in layers branch by typing branches. So this is the way how you actually switch from one branch to another branch. Once you are in a particular branch, any changes that you do in the source code goes to that particular branch. So once you do a push, right, it pushes to that particular branch. And how do the process of moving the code from a specific branch to another branch is done via multiple steps. So you might have heard about pull request, merging, and so on, right? So that is a process in general practice any company actually does. You make your changes in a particular local branch, and then you actually create a pull request to merge into the main branch. So that is how it works. So for example, you have a code called this, you have a repository, you have this branch. Now you want to create a pull request, then there is some section called pull request, right? Pull request. I think I don't have changes here, but this is the way actually. So So to create a pull request, there is a button called new pull request. You just need to click on new pull request, and from which branch to which branch you want to pull, you have to mention. So in this case, you want to, for example, you want to pull request from layers to main branch, right? So you say that this is your branch changes present in layers, and you want to match those changes into main branch. So you have to give the source and destination branch both. So source which is called base branch is layers, and here the destination is the main branch. You can give any other branch also of your wish. As an example base, I am giving a branch called main, and you can just create a pull request here by clicking on this create pull request button. So the same, there will be a command line variant of it. You can use command line commands also, but you can do it using GUI also. Okay, so these are the basic fundamental things every engineer needs to know. How to pull, push, how to commit, how to create a branch, how to create make changes in a particular branch, and try to merge it to master. How to merge it to master by creating a pull request. So these are the basic fundamental things that any GitHub user needs to know. So I am just covering all of them. Okay. Okay, so we moved to we covered few fundamentals of Git. Okay, we can discuss more and more on GitHub. Okay, so we have another way. If you want to create a new repository from scratch from your local machine itself using your terminal command line, then there is something command called git init. Okay, so this is generally nowadays nobody, I would say it is not required, because branch is created only once, a repository is created only once. You can just create the repository using GitHub. You can go to repository and click on this particular button new, it will create a new repository for you. And once you have a repository, you can just use the git clone button to clone the repository. So general practice you can create a repository using git init, but generally we can just create repository using GitHub. Yeah. Yeah, so what else? Yeah, so I already showed you example of how do we actually push the changes from your local repository to the remote repository. This is the command git push origin master. This is the command. Please go through the slide once again. Feel free to ask questions if you have any. I think everybody knows about Git. We are just warming up. Yeah, so we already covered this. Yeah, so we already quickly covered all these things also quickly. So we have seen add command, commit command, remote command, push also, and we have also seen it how to do via terminal and how to do via Visual Studio Code also. We have seen in two places, not only in using terminal commands, also we have seen how to do it using Visual Studio Code. And this is the most, I would recommend doing it Visual Studio Code because it is very handy for you. You can see, visualize the changes here only. And you need not switch from the IDE back to the terminal. You can do everything in your favorite IDE itself. And in Visual Studio, we have something called terminal here only. We need not go to terminal. Here we have separate terminal. You can type all the terminal commands here only. So I can say present working directory. I can clear the screen, CLEAR. I can see list of all files, ls. So this is a proper terminal. Visual Studio has provided to you inbuilt in its IDE environment itself. You can type everything here, all terminal commands, ls, pwd, dir, mkdir, or any commands, you can just type it here itself. You need not go back to the terminal tab. You need not go here. So you can type everything here. It makes your if all your development process is actually concentrated here itself, you can code here, you can type terminal commands here, and you can actually commit your changes using GitHub extension here itself. So that's why Visual Studio Code, or maybe like it is there in other IDE also. Visual Studio Code is more friendly when it when you want to make any changes or develop any software. Like all end-to-end can be done within the dev IDE environment only. Okay. Okay, all right. So we covered the basics of GitHub right now. Yeah, so these are the basic things we need to configure. Hello? Yep. So
Anil?
yeah.
Yeah, I need one clarification. So in the DevOps, so once the code is built by using the Maven tool and all, so after that it will go to the Git repository, or in between we have a test tool. How it is the process?
General process is to go to the GitHub repository. Build happens as a prod. If you're a DevOps engineer, if it goes to the repository, it has to go through via different checks. Okay, so as I mentioned, to go to the repository, we need to do the git commit commands, right? Git commit, git push, all these commands we have to do. Okay, so so once you do all these git commits, right, we can actually provide a continuous integration. We can provide integration tool, continuous integration tool inbuilt in your git repository to make, to run the build, to run the tests automatically whenever a commit happens. We can do that. So suppose like,
Oh,
suppose you want to make your changes, and you want to commit your changes to your repository, right? So as a DevOps engineer, what you do, you create a set of rules. You integrate, suppose you integrate a Jenkins, you integrate a Jenkins infrastructure into your repository itself. Okay, there is a mechanism. You install a Jenkins server somewhere, and you hook your Jenkins repository with the GitHub repository. So you hook your Jenkins server to the GitHub server. Okay, you hook up. You say that whenever a commit happens, automatically Jenkins should run all the build process, taking the help of Maven. Okay. So your question is like how the Maven build, you created Maven build, right?
okay.
You created Maven build,
But
but as a part of,
without a build, can we able to push the source code to Git?
yeah, so we can configure that. We can configure that. So we can in GitHub we have different hooks. So there is git commit and git push both, right? There are two things, right? Git commit actually pushes into a local repository, right? Git push actually pushes to a remote repository. And in GitHub, there is something called hooks. I'll just show you that actually. So in GitHub, something called hooks, right? Suppose we have one repository, and here I think in settings, webhooks, we have webhooks, right? Okay. So we can actually create a hook, something called add webhook. What is your password? Okay. So you can actually create your own webhook here. So you can mention when the webhook should be invoked, right? Which events would you like to trigger this webhook? So just push event or send me everything. We have to, so this is in this example, right? This example say that whenever any push happens, invoke the particular webhook. Okay, so the webhook should go to one particular CA server, continuous integration server. In this case, in that case, it can be a Jenkins server. Okay. Okay, I will explain you when I actually say you in Jenkins. When I come to Jenkins session, I will explain you by step with that. Huh? So what I wanted to show you that, so we can enable to run the build, run a particular build when you do a git commit or when you do a git push event. When you do a git push event, when you do a git commit event, you can run a set of Maven builds, like Maven, run the Maven build, run the Maven test. You can enable that all this, or you can make all them running. And based upon the status, you can actually send alert to the user whether you can proceed or whether your commit was wrong or so on, whether your tests have failed, whether your build was unsuccessful. You can actually send the status of it. Okay. So let me explain again. Let me explain again. I will give you a demo when I come to Jenkins. I will give you a complete demo. So what I wanted to explain is like, you can integrate our CI/CD tool management tool to run all the Maven builds. In this case, if our repository is working on Maven, so all we need to do is like, we have to run Maven task, right? Maven run, right? We have to run to build, to test. We have to say MVN test, right? So we have to run these commands, right? So we can ask our CI/CD tool, CD tool to run all these commands, MVN build, MVN test commands whenever a commit happens. And we can actually restrict it from actually merging into the main branch or merging into the sub branch. We can set our own rules based upon the business needs. If we want to stop it to push into the main branch, if build fails, we can do that. Okay.
I have a question. Can you hear me?
Yeah.
Yes, so you would, what I'm understanding in this webhook is that if you are going to do a webhook between your branch repository and the Jenkins repository, upon a commit to your branch repository, it sends a webhook, and basically the Jenkins rebuilds your code. Would you not have to do a pull request to your branch before you would do a commit up and then have it built? In other words, are you building at your branch level before you push into master? Is that what it is?
Yeah, right. So before you push into the master, in your branch itself, you can configure, you can send the status of your commit using Jenkins, right? So so we can find the problem itself before pushing to the master. So
that was my question.
Based upon your business needs, I think we can even stop it from pushing it to your master, pushing it into your branch itself and identifying it via commit itself. When you actually do a commit itself, you can actually enable stopping it to push it to remote repository if it is a failed build. But general practice is like, when you actually push it into a branch, it actually via webhooks, it runs the build process in your Jenkins server. The Jenkins server runs the build process, finds any error, then it provides the appropriate alert message, the error message saying that the build was failed for this particular commit in the branch. Yeah. Yeah, we will.
So how does the Jenkins, how does it update the code for the Jenkins build? Is it because the Jenkins is pointing to your branch code?
Yeah, so imagine that Jenkins is actually running in a public domain. Okay, you have a Jenkins server running in a particular, it has a public IP address which is reachable from GitHub. Okay, so in GitHub, for example, you have seen in GitHub, you have the webhooks, right? In webhooks, you can actually mention the URL right here. Here you have the URL, right? So in this URL, you actually give the Jenkins URL. where the Jenkins server is listening to, right? So once you have the URL of Jenkins mentioned in the GitHub, whenever you do a push, then GitHub will send a build request, or it's send a trigger to the Jenkins server to run all the commands as a part of circle integration. So which happens basically as a part of Jenkins file. So there is some file called Jenkins file. Jenkins file. There is something called Jenkins file, which actually Jenkins understands, which is part of the repository itself. So this Jenkins file will have all the commands, like for example, maven build, maven test, etc. Right? Or any other specific syntax related checks, or whether indentation related checks in case of Python. All this checks, everything can be written in file called Jenkins file. So this Jenkins file will be deployed, will be as a part of code itself. Like in the code repository itself, you should be having that particular file. So in this particular example, for example, I can actually create a Jenkins files right now itself. So I can just create a new file called Jenkins file. And write all the Jenkins related commands here. So Jenkins file will follow some syntax actually. So how to run different tasks, right? So like Jenkins file, I can just use this particular example. So like, so you will be having this one, right? So as a part of build, you can run, in case of maven build, you can say maven run, or maven build, maven compile. Yeah. So to build, for example, so there is a command called maven compile. So to run test, there is something called maven test. So we can run different tests in different stages. So this Jenkins files will be part of the source code itself. I will commit this file. Okay. So now this particular file, this particular repository is there, right? This repository is already having a Jenkins files which has set of instructions, maven compile, maven test, and so on, right? So it has set of instructions, and this Jenkins file will be executed via the Jenkins server. Okay. So once you have a hook, once you have your GitHub repository is having the hook, and you have, I haven't set up a Jenkins server yet. Suppose your Jenkins server is already running in some cloud, in some cloud in a virtual machine with some particular IP address. For example, you are running in AWS with IP address some XXX. So XXX dot XXX / Jenkins. Suppose it is running here. So what you do is like you you go to the Jenkins dashboard and provide the repository URL. Basically the repository URL, you can find it from here, right? So this is the repository URL, right? You just give this repository URL to the Jenkins server. So Jenkins has its own dashboard. I don't have the Jenkins configured yet. I can show you an example. There will be some Jenkins dashboard. Okay. In the Jenkins dashboard, you can actually add a GitHub repository. So I will show you in the next session. Okay. So you can just say Jenkins, for example, Jenkins. You can just type for Jenkins GitHub integration. Here it will give you step by step how to do that actually. So there will be some place, some section where you have to give the repository of the GitHub. So you give the GitHub repository, in our case, the GitHub repository, you can just copy this particular GitHub repository URL. And once you have your Jenkins dashboard server ready, right? In there will be some section called Git. In that Git section, you have to give your GitHub repository URL, which is this one, what's.git in our case. You just copy that URL, then Jenkins knows which GitHub to actually run, right? So it will, Jenkins master will actually configure a slave to build all the commands which you already provide in the file Jenkins file, this file. So it will just blindly execute all these commands. The Jenkins server will configure a slave to run this particular file. So this file, all these commands will be executed. And if any error happens in any particular stage, you can actually say it will actually display an error saying that this particular stage was failed because of some reason based upon your Jenkins file configuration. In this case, you will just say that the stage build failed if Maven builders failed. Okay. I will explain you step by step when it comes to the Jenkins session. When we are actually visiting the Jenkins section, I will explain you all the steps.
Thank you.
Okay. Okay. Yeah. Yeah. So now we have already touched basic commands of Git. Yeah. So these are all the commands. Few other commands. So there is something called Git status, which I already mentioned, which actually gives you different output of what is the status of your GitHub repository, what are the changes to be committed, what are the changes not yet committed, what are the untracked changes. Untracked changes are those files which are newly introduced, right? Which are newly introduced in Git. So there is something, a very important concept called git ignore, .git ignore. So we have got .ignore file to ignore. So if whatever files we mentioned in a .ignore file will be completely ignored by the GitHub repository. So it will not be part of the version control at all. So even if the files are present in the directory, it will just ignore it. So we don't want our builds, our debug files, log files should be as a part of the commit, right? We can always put all of them in a file, something file called git ignore. So I already have here, like for example, here, this is an example of a typical git ignore file for Python file. So here it will read this file to see what files it can actually ignore. For example, it is ignoring all .log files. It is ignoring .mo, .pot files and so on. So yeah, so this is one concept of Git. Suppose you want to, if you want to get to ignore few files and few extensions, you can always mention file. If you want to ignore a particular directory, you can always mention that particular directory. It will literally ignore all those directory contents. Okay. So what else? Yeah, so this is already, I have already covered git tag. So as a part of release cycle, we generally use tagging. So this is the it is not like mandatory, only it is used for only release purpose. We can tag any kind of commits so that it is remembered tomorrow. If you want to see back, track that particular commit in a user friendly way, you can actually retrieve that information using the tag information. So this is one important concept, adding tags. And generally, git tag is used as a part of release process. So for every release, you just create a new version with that particular tag, and people can actually remember that that particular commit hash belongs to this particular version release. Yeah. Yeah, so if you want to revert some changes, we can do using this particular command called git reset. Git reset, we can dig deeper. So this is a general syntax of git reset. There are different configurations, soft, mixed, hard. We can relate to we can relate this soft, mixed, hard to different stages, right? Different stages of your commit. For example, like if you want to revert your changes, but you want to keep your working directory, you just put soft. If you want to put it in a state changes, you put it as mixed. If you want to completely remove all your changes, uh, remove all your changes that you have committed, then you can do hard. So this is just look into it. If you want to dig deeper, you can experiment on soft and mixed and hard for different repositories and see how it goes. So basically, these are the different. This helps us in keeping the changes in your local repository or not, whether you want to keep it in stage repository, stage changes or not, or if you want to completely remove all your changes from your local repository, based upon your requirement, you can actually reset it. So that is the reset command, which is very handy. Yeah, so there are other commands. I have already covered git fetch, also git pull, also git push. I have already covered all of them. Yeah, so I already covered branching, merging also. So let me know if you want to discuss in detail about branching, merging. We can actually work on it detailedly. Otherwise, we can actually, I will assume that you all know. Please look into it, how to do branching and merging. This is an important concept which every software engineer needs to learn. How to branch it, how to merge branches to end the branch. Most probably it is done to master branch. Yeah, so this example actually shows you how to actually add a step-by-step feature of how to add a particular feature to a public repository. So this is a typical process, typical general process being followed. Whenever you add a particular feature, you always develop it in a new branch. You create a new feature branch. Once you create a branch, you have to switch to that particular branch, and then you make changes in this particular. We have given a simple example of making changes. So here we made some few changes here, and then after you make the changes, you can actually work on yeah, so after this you can actually do merge it to the main branch, or by doing a PR request and merging to the branch. So this is the steps how to do a PR request. So you go and log into the pull request, click on the pull request, create a pull request, and then if it is most probably, if it is does not have any conflicts, then you can actually merge the pull request to your master branch. So this is the typical cycle, general code changes, how the code changes are done and merged to the branch. Yeah, so this is the diagrammatical view of how the branching is done. So this is the main branch, and this is the sub branch. So in this case, you have created a main branch. We have a branch. We have sub branch we have branch for the sub branch. So we can create. We can do cascading branches. So branch can be having another branch, and the branch can be having another branch, and we can directly merge the sub branch to the main branch also. Provided it doesn't have any merge conflicts. In case you have merge conflicts, you are supposed to resolve the conflicts. So typical resolving of conflicts can be done. Yeah, so resolving conflicts, actually it's a good topic actually. I hope you all guys know. So resolving conflicts is not covered here. If you know, I can give a demo of how to resolve conflicts while merging. So there is some concept called squashing. So the basic concept of squashing is like you create a branch and you have multiple commits. You have multiple commits in that particular match. Suppose you want to merge all these multiple commits into a single commit. If you want to combine all the multiple commits into single commits and then merge into the master, then that is something called squashing. So you squash all those commits into single commits, which makes sense, so that when you see into the master, you see it as a single commit. So that is basic idea of squashing squashing. So that comes as a option when you actually merge into the main branch. So when you merge in the main branch, you have a button, merge pull request. There when you click on the down arrow, you can see squash and merge also, where you can actually squash all the commits. Yeah, so we have covered the basic fundamentals of GitHub now. The basic fundamental GitHub. We'll cover more and more. Probably like we'll dig deeper, advanced topics also. We probably like, so GitHub itself, if you go through this UI, you can see there are lot of options that you can actually see in the settings. Settings, you can see that you can generate. I have just mentioned about webhooks, but there are many other things like deploy keys. We'll cover that if needed. Deploy keys, other than deploy keys, there are something like wait a minute. Yeah, suppose like in profile settings we covered SSH key, GCP keys. Other than that, we have developer settings. We have something called personal access tokens. We have personal access tokens also. So we can generate our own personal, have a look into this also. This is also very handy. We can use it. We can generate a new token and assign this particular new token to specific cloud environment. So once you create a personal access token, this token can be used in other machines also. So basically, so have a look into it also. This is one other important thing that we can actually explore. Yeah, so if you dig deeper, there are a lot of things to actually that we can actually learn as a part of GitHub. We will actually look into one example. When we come to Jenkins, we will actually more dig deeper and do a running demo of how the webhook works actually. We'll look into it as a example. Yeah, so let me know if you have any other questions. So I think we are good with GitHub now. We think we will move to next topic. So as we have more time, let's move to next topic then. So next topic, let's cover. Let's cover. So have a look into this GitHub slides as well. So these are actually duplicate. Actually, they all are covering the same topics. Probably I had to ask our team to actually remove these slides. They are repeated. So it's we are comfortable with the this one part one version control part one should be sufficient enough, and probably the second control part 2 is almost containing the same topic. We need not have this. And next topic maybe like this one, getting started with GitHub, is like a hands-on tool where I think we can actually run few of the commands here itself. This is a particular use case of how to create a repository and so on using the Jupyter tool. You just need to log into your Jupyter tool and follow the instructions so that you put yourself handy when you work on GitHub, how to hands-on on Git. It will give step-by-step instructions. So just have it look into it. So it will give each and every instruction. Just follow the instructions. How to create a Git repository using Git init. And so how to configure username, how to configure user email. You can just run them in your Jupyter console. So just follow these instructions as a homework and you will get familiar with GitHub. Yeah, so just follow this. It contains only 16 steps. Just follow the 16 steps to put your hands on in GitHub. So
Anil, can you cover the SSH piece again, if you don't mind?
yeah, sure. SSH means like how to create a SSH key, right?
Correct. And how to download using that?
Yeah, sure. Okay, that's a good question. Yep. So WhatsApp bot, right? WhatsApp bot. You are supposed to have the SSH key in settings in SSH GCP keys, right? Okay. So here the steps are already mentioned. Let me iterate over it, or you can online see any other steps. So basically, it is a confusion when you come work in large companies, right? Nobody actually says you how to do that. You are expected to know everything, right? So the basic concept of SSH key, if you are in a Mac machine, right, you have that handy commands, right, for generating SSH key. SSH-keygen is the command. It will directly work in your terminal. It will automatically work in a terminal. So all you need to do is like run that command, SSH key commands. So I already mentioned, right? So to type the SSH key, you have to first generate the SSH key. I have already generated SSH key, but I will regenerate it. Let's see if it works. So I am recreating. It is already there in my machine. So I will say override it. Yes. Yes. Enter phrase, passphrase. I'll give some more passphrase. Or no passphrase. So SSH key is generated, right? So now SSH key is generated. It will be generated in your local directory. So in your local directory, you can find it out in your home directory. In your home directory, there is a hidden folder called .ssh. Okay. So go into that as a hidden folder. You have a private key and public key combination. Okay. IDRSA is a private key and IDRSA pub is the public key. Okay. Now you have to copy the public key in the GitHub. So go to SSH key. I think it will clearly mention you new SSH key. My key, and you have to copy the public key. Go to the public key ID underscore RSA. You have this public key already. So I have private key. So go to the public key. Okay, so this is the public key. Just copy this particular public key. Okay, now you have the public key already here. You copy this public key, add, make sure that you don't have any spaces, or you just add this key. Now you have this key already added in your GitHub. Now this GitHub will use your public key whenever you try to clone a repository. Now you're done. That's it. Now you have to clone your repository, right? So you have to go to any repository which you are supposed to clone. For example, you have to go to a private repository which will ask for credentials, right? So I need a private repository. Generally, public repository doesn't need any credentials, right? So let's see. So imagine this is your private repository. Go to your SSH command here, SSH, copy this particular URL, which is SSH specific URL. You copied it. Now just do git clone. And now go to any specific folder. I don't want here. Now you do git clone and this URL. Done. Okay. Okay, already let me remove that. There is no directory. Now try to do git clone. Now it is a public repository, right? So it directly downloaded it. Let's make it private repository. So let's make it private repository. How to make it private? To make so GitHub to make a private repository private, you can just go to the repository settings and I forgot it. So it is public repository. I forgot where, how to make repository. So we have something like make it private. Privacy, I think. Code security analysis. Actually, I forgot where, how to make. Under repository name, click settings, and under danger zone, right, change repository visibility. Under danger zone. Went to settings here. Danger zone. Here you can make the repository. Oh, I can't make it. Okay. Okay. So this is the fork, so I can't make it visibility. Let me go to any other repository. Let's say I go to this. Let's say I have a private repository. Let me search for if I already have a private repository. So let's say this is a repository. I have private repository here. So this is private repository, right? So I have the SSH key. Now here, this is the SSH key. Now let me see, do git clone. So you're successful, right? So I did a git clone using SSH key, right? And it is trying to pull the code. It is successfully able to pull the code, right? Because I have already configured my SSH key, right? To configure the SSH key, what I did, I went to the settings. In SSH key GCP things. I just copied my public key, my machine public key here. Because I have a public key here, I am able to clone my private repository. the private repository will always ask for credentials, right? But in this case, it didn't ask for any credentials. It just cloned it, right? It just cloned the entire repository. This particular repository, Uber deck, in this particular repository, Uber deck, right? This Uber deck is a private repository. It definitely will ask you for credentials. If you want to clone it, it will ask you for credentials. But because I have already added my public key in the GitHub and my private key is already there, it is already there in my SSH folder. The hidden directory is there, right? Which is there in the home directory. You can see that in .ssh folder, right? In this folder, I already have IDR as a private key, and its public key is already configured in the GitHub, right? In the GitHub, it is already configured. I added the public key here, right? So because of that, it was able to clone my private repository successfully. So this is the way you actually do a git clone using SSH.
So when you use a git clone, then it is using your private key to communicate with public, is it?
That's what, yeah. So your public key is already configured in GitHub and private key is in your machine. So it is able to clone. Yeah. Okay. Yep. So anybody have any more questions, please? Okay. Yeah. So just run into your please run into the demonstration, getting started with Git. Do this homework. Try to run to look into the video or follow these instructions and put your hands on Git to get yourself familiar. Okay. And also as a homework, also try to learn. This is another important concept in your settings, in your developer settings, you go to the settings, go to the developer settings, personal access token. So this is also very much used nowadays, personal access tokens. So just have a look into it, read about it. When you integrate Jenkins with your GitHub and all those things, right? So then you use public tokens also. So then use personal access tokens also. So just have a look into these personal access tokens. We will do some hands-on in the next upcoming session when you actually do CI/CD using Jenkins. We will do that. But before that, just try to get an idea of what is personal access token is. It is another important concept actually. Yeah. Yeah. So there are other concepts which might be of interest to you. Yeah. So the basic fundamental thing, I hope you all know, like collaborators. There is a collaborator section which I missed to cover. For every repository you have a set of collaborators. You can add collaborators by going to that repository specific settings in collaborator list. You can invite more collaborators to your, which is scoped only to that particular repository, only. It is repository level. Yeah. So similarly, like, yeah, so other things, maybe of deploy keys. Deploy keys is also of interest. I will cover them later. For now, we don't have any specific use case. So if you find time, also read about this deploy keys also. So when it comes to deploy keys, personal access token, SSH keys, they may be confusing to you, but they have different purpose. So try to read about deploy keys, SSH keys, and personal access tokens. So that will help you understand about what the keys are, where are they being used in different cases. Okay. So when I come to hands-on, I will try to give a demo of how to use the personal access token. I have already given you a demo of how to use SSH keys, right? I have already given you a demo of SSH keys. So these things are very useful when it comes to when you are using. You should be able to identify the differences once you have an hands-on of what keys are used in different which area, it will be helpful to you. Yeah. Yeah, please go through these steps, and later tomorrow we'll actually start with the Dockers. So before running Dockers, I will try to cover basic terminal commands, Linux commands, and also I'll try to cover in the next session what are the cheat sheets a typical DevOps engineer should follow as a part of Linux commands. So what in general, how do a DevOps engineer runs looks into the logs? How can he run head detail commands to look into the top 50 lines of a particular log file, and what is journal D, what is system D, what is system CTL. So these are the basic Linux commands, not basic, the fundamental Linux commands a typical DevOps engineer needs to follow. So I will start with the basic Linux commands, and then I will dig into Docker. What is Docker? What is container? And how to hands-on Docker, and how it is used in our cloud platform, whether it is AWS, whether it is Azure, how it is being used. So I will cover all those topics tomorrow. Today we are out of time. I'm just giving a general overview. Not tomorrow, next session. So next session I will be covering Docker and the cheat sheets of a typical DevOps engineer and basic Linux commands. So these are the topics which we will be covering in the next session. And if time permits, we will go to other topics as well. Okay, so today we'll close this session. Please let me know if you have any questions. We will continue.
Yeah, I want to get one clarification on the private key in a private repository. The only way you can, in my understanding is the only way you can clone to the prior repository, the only option is an SSH. Is that correct? Or
Yeah,
I'm trying to,
yeah,
yes.
the private key is not supposed to be given to the GitHub.
Yeah, I know. I'm aware of that.
Yes.
Right. But in the private repository, when you're working with a repository, the only way you can clone a private repository will be through SSH. You have three ways of cloning, right? You can clone zip, you can clone HTTPS, you can clone SSH. So I'm just trying to understand, why do you need to have involved an SSH key in a cloning situation? Is it because to confirm who's cloning your private repository, or is there a reason?
So if you are using zip, right, I suppose you are zipping it at there itself, right? So here you are already logged in as a GitHub user. So you get into this particular place, you get into a repository in your browser after you log in, right? That means you are already authenticated. So zip doesn't require any specific extra authentication. In your browser, you have already authenticated, you have provided your username, password, you are logged in, you get into your repository, you are the sole owner of your repository. That means you can just download the zip. That should not be a problem at all, right? But imagine that you are in a completely different machine. You have not logged into your browser there, but you want to get a copy of your repository. You have the URL only. You have the SSH URL. This is the URL, right? So you have this URL. Somehow you have to give the credentials, right? So credentials, you can either give credentials using HTTPS, or you can give a credential using SSH way. So if you give HTTPS, right, it is generally like it is expected that you need to type your username and password, right? So which is specific to like when you actually you are not supposed to type your password. You're not supposed to expose your username. You are not. Some companies are not willing to take personal username and passwords. Personal username password when you actually commit your code, right? So they generally rely on SSH keys when you are actually authenticating in industries. Basically, they prefer SSH key because there is no specific username password associated with it. All it cares about mapping of public key, private key. Whether the production machine, suppose you are cloning the repository in a machine, a production machine of a company, right? So you are independent of the username and password. You just need to have the private key and public key combination. The public key should be there in the GitHub repository, and the private key should be there in the machine, in the trusted machine, right? So people need not care which username the SSH key was actually generated and so on, right? They are username agnostic at least. So generally they prefer SSH key there, and it is more protected. Well, you can actually mention the SSH key as an environment variable when it comes to any specific configuration tools like Ansible or maybe Kubernetes. There we can actually mention the SSH key or Jenkins in case Jenkins. There you can actually mention the SSH key as a secret file which cannot be seen directly, right, as a secret key. So in those cases generally they prefer SSH key only, which makes sense, right? Instead of giving your username, your specific password, which can be a security threat, right? So for that purpose, most of the time SSH key is being used. But if it is a private repository, your private computer, your personal computer, then generally you can just go up with HTTPS.
Thank you.
Okay. Okay, then guess we are closing this session for today. Let's meet in the next week, Sunday, 8 p.m. then. Okay, guys. Thank you.
Thank you.
Yep.